Welcome students. Today is the concluding class for digital land surveying and mapping. In this class I am going to summarize about the different lessons that has been taught in this course and how they are relevant to our digital land surveying and mapping, that I am going to summarize. 7 topics broadly I had discussed, that is fundamentals of digital land surveying, then fundamentals of GPS, fundamentals of total station, then errors and its propagation, vertical representation, fundamentals of mapping, and followed by the demonstration of digital land surveying and mapping. Now why I have gone for fundamentals of DLS, that means digital land surveying and mapping, and what are the contents and how it is relevant, that I will be talking now. So the first 3 lectures I have discussed about the digital land surveying, its application, then the basics and the overview of digital land surveying. As you know, I have explained that the surveying is the fundamentals for any engineering work. So engineering survey is the prerequisite for any engineering planning, engineering project planning and design, and then to be constructed in the field. In order to do that, we need to have a map, specifically a topographic map of the area, which provides us the information about the different objects present on the surface of the earth or surface of the project area, as well as how the relief of the terrain varies. So these are the informations which we do collect through surveying or engineering surveying, and this is carried out by making use of the basic principle of surveying, that is from working from whole to part. And to carry out the work we need to go for many different stages of operations. However, to carry out these works, actually we do fundamentally make some measurement, which is known as surveying. So to carry out this survey, actually we make use of many instruments. Now over the period of time, these instruments are improving day by day, and the state of art of the surveying is to make use of some instruments which are precise as well as those provides the digital data. So that is the basics behind our whole of this course, how to collect or what are the instruments to be used for collection of lands data and to prepare digital map. Now in the overview I had discussed that the digital land surveying or any land surveying consists of primarily 2 parts. One is to establish the control point and then to find out the detailed objects or location of detailed objects and their nature. So in this course we have discussed that the control points for digital land surveying is being collected, can be collected nowadays by making use of a latest equipment known as GPS, Global Positioning System based digital data collection, and the details of the terrain should be collected by making use of a instrument called total station. Measurements from both these instruments we can get in digital format. So we have taken up these 2 in our subsequent modules of classes. So, in the next few classes from lecture 4 to lecture 16, I have discussed about the various nuances or points that is related to global positioning system that is relevant to our establishment of control point using GPS. Now, in these lectures I have talked about what is GPS, what are the different components of GPS, with special emphasis on the component which are relevant to user. That means it is the GPS receiver and the software, and basically we make use of the signal propagated by the GPS satellites which we receive by making use of GPS receiver with the help of GPS software. And this data which we or signal which we receive, GPS signal we receive, we make use of the principle of analytical resection to find out the position of points. We get GPS position in WGS coordinate system that has been discussed, and to collect the data we have to make use of different methods, and those has been discussed. As a result of this collection we really get two fundamental observables that has been discussed. However, before we make use of the observables we need to know what is the quality, and the quality of the observables depends upon the errors, different types of errors that are associated with it. So, I had discussed on this, and to improve the quality of the GPS position we need to first remove the errors. So, we should go for pre-processing, and after the quality of the data to be processed is of sufficient standard, then we should go for its processing, and processing has been done, is being done generally by point processing or baseline processing, and later we go for network adjustment so that we can have our position of control point within the standard specification. So, I had discussed about the standards, different standards that may be or that should be adopted or that may be adopted, and how to measure the quality of the position. And also in between the classes I had demonstrated the different GPS receiver, so that the participants have a feeling really how it does looks. And then also I had also demonstrated the different software which are used for operating the GPS receiver as well as processing the data to end up with this GPS position, and the methods that we generally adopt for establishment of control point. So, now to summarize it, actually for establishment of control point using GPS, first we should know what is the specification standard which we have to achieve for our control point. Depending upon the specification or standard to be achieved, we should first plan our GPS surveying work. Now, to plan the surveying work we should make use of some planning software which provides us the possible observation window, session and other detail about the availability of the GPS satellites as well as the quality of the data we may expect to have. And then after planning we should go for actual location of our station points, and those station points has to be good enough to not to have the multipath and other criteria has to be satisfied. Then once this is done, then we should go to the field for actual observation, and during observation we should go for some initialization process. We should place the instrument properly over the location of station. Before that we should also select the instrument of proper quality, so that the data which will be collected using GPS should have the capability to meet the requirement of the specification. In case of establishment of GPS control point, we should go for frequency receivers, preferably multi-frequency receiver, and we should go for static method of surveying. We should go for epoch, maybe of higher duration, maybe 15 second, 30 second, but we should say that the GDOP should be least like between 1 to 2 or 1 to 3, and then our cutoff angle should be as per the need of the field. The station should be free from any electrical interference or reflecting surface around. So these are the some salient points we should look into, and we should take the observation duration as large as possible, and before we took the observation we should know how many GPS receiver we will be using, so that our observation design or observation scheme should be properly followed. So all those things we have to do. Once the data has been procured, then we should test the quality of the observables, and that has to be tested by making use of the quality measures. And then once our data has been satisfactorily procured, then that data has to be transferred to the office computer through interfacing software, and depending upon the requirement, like if we want to go for post processing, we should prefer for scientific post processing, and we should go for precise ephemerides, and precise ephemerides should be preferred to be taken after 15 days. So if we want to really do a very high order, high quality GPS topographic surveying, then our establishment of control point should be done at least 15 days before the total station work or detailing work. So this is what we have learned from fundamentals of GPS. Then we have discussed about the fundamentals of total station and fundamentals of total station. In this we have the lecture number 17 to lecture number 26, in which basically I had demonstrated and discussed in detail about a different types of total stations, and total stations generally make use of a reflector, or sometimes we can be used in a reflectorless mode. Of course, before setting the instrument also we should test whether the total station is permanently adjusted or not. Then I had discussed about the different ways how measurements can be done using reflector, without reflector. The measurement parameters are horizontal angle, slope distance, distance and direction. Direction may be horizontal angle and vertical angle, and distances the slope distance. I have discussed about the different arrays that is involved in total station. Then I have actually demonstrated a total station and its working and operations. Whatever we have learned from this is that in case of digital land surveying, the detailed information about the land surface, that means the different objects present on the land surface, we do collect by making use of a total station. Depending upon the specification of the data to be obtained, we have to select the type of total station, and after selecting the total station, first we should ensure that the total station is free from permanent adjustment, and then we should make use of reflector, preferably if the distance of the object is more, and in some inaccessible areas we can make use of reflectorless mode, but provided the distance, that means of the inaccessible point or object is less. After that we had discussed about the different errors that may appear in our different surveying measurements and its propagation, and in the lesson number 27-28. So what we have found in this, that there are different types of errors, and it gets, whenever there is error in some measurement of GPS parameter, that gets propagated to the computed parameter. As a result, we should know what is the way, how does it get propagated, because the specification of the surveying map will depend upon not on measurement but on computed parameters. So to satisfy the need of specification for mapping data, these lessons are very important, and we should see whether the amount of errors in measurement lead to error in computed measurement, and whether within the specification to be met for the data to be prepared, to be used for mapping. Later, next, the our engineering survey demands to have the map in 3-dimensional depiction, but because map is a plane surface, so it is not possible the way it appears in the field. So we need to know how to represent the vertical dimension, third dimension, in a 2-dimensional surface, that has been discussed in lesson number 29-30. And in case of civil engineering projects or most of the topographic map, generally we make use of contouring or contours to represent the vertical dimension, and that has been discussed in this class. So whenever, so digital land surveying, when we will go for land surveying, we should also know what should be the scale of the vertical representation, that is termed as contour interval, and depending upon the scale for vertical representation, we should also do our digital land surveying, that means detailing. That means during detailing we should also collect information about the spot levels and the frequency and the quality of the spot levels should be as per the need of the vertical specification, that is contour interval. Then once the data has been collected by digital land surveying, that means once the control point has been established, and then from using the control point we will go for total station to collect the detailed information about the objects as well as spot levels. We will now go for mapping, representing the measurements. So to represent the measurements in a map, in the form of a map, we need to know some fundamentals, and that is been discussed in lecture number 31-34. And in case of digital mapping, actually we make use of some software which really does the fundamental works. Of course, still now we need to have many interfacing work to be done by the operator, and the quality or the nature of presentation, or about the whether the representation is correct or not, and many other activities that the software does need the interference of the operator. However, many of the works we do using the software, so we need to know about the softwares also, and also we need to know what is the sequence of steps that has to be done by making use of software. So all this has been discussed in this lecture number 31-34. So in case of our digital land surveying and mapping, once the digital data has been collected and made it relevant to for mapping, then first thing we need to whether the data has been collected to be represented satisfy the will be able to satisfy the specification of mapping or not. That has to be tested, and for that testing we need to know what are the specification really we need to have for our mapping. Like the most important specifications are the scale of representation, it is the horizontal scale representation or planimetric scale representation, and the vertical representation, that is contour interval. Finally, I had discussed about the digital land surveying and mapping in detail steps. Also I had demonstrated a few things, most of the things I have also demonstrated, and ultimately I end up with a map which is a topographic map, and that has been done in lecture number 35 to 39. Now in the beginning I had discussed about the digital land surveying and mapping. So in digital land surveying and mapping I had shown that how to establish a control point using a GPS. We had used a geodetic GPS receiver to establish the reference receiver on a reference station on the rooftop of one of our building, and then I had shown how to set up the instrument over the station. Then once it is set up, then we have to make it on, and then after making it on we have to go for opening the project, and then we have to set up many initialization parameters. Then once the parameter has been set up, then we should say what is the epoch of observation, what is the cutoff angle, all those things I had shown, and then we had left the instrument for it to observe the data, take the data. And then I had also shown another receiver which has been placed as a rover receiver, and then we have to take in the data. But further I had shown that the reference receiver, first we will like to establish the location of the station with respect to IGS station which are spread all over the world, and they are termed as VRS, virtual reference system. Actually during the duration when we have taken the observation for our reference station, also there are hundreds of receivers which are taking observation all over the world at the IGS stations, and we try to find out what are the receivers, what are the IGS stations where receivers are collecting the data during the same time when we were collecting. Not only that, the epoch of observation of those stations should be equal to or less than what we are taking. For example, we have taken the epoch of observation 30 seconds, then the IGS station data should be available at an epoch of 30 seconds or less, that means maybe 20 seconds, 15 seconds, like that. So after identifying the VRS, we had processed the data, I had shown it, and once not only we have to download the data of the IGS station, also the actual coordinate of the IGS stations has to be downloaded. Now we had to, during processing, the location of the IGS station will be obtained from the measured value, and that has to be substituted by the actual value. Then we should go for processing of that data with respect to our reference data. In that way we will be able to place our location of our reference station with reference to IGS station. Once that is done, then we can say that our control point has been established. Once the control reference station control point has been established, then in our project if there are some other control points, then those points we should establish with respect to reference station using the same method. Only thing is that in this case we have to make use of our own data, and this can be improved as I told you by taking the precise FMNS data. Once the data has been procured, that data will be that location of the control points will be available in WGS84 coordinate system, which is either Cartesian or in geodetic system, and then to make use of that control points in our detailing purpose, first those points WGS84 coordinates are to be converted to our northeast and orthometric height, and for northeast and orthometric height I had shown you that it has to be first converted to northeast orthometric height by making use of some other software where it will be required to give this control point location data as well as the projection system UTM location of the data like 43N I had given for our place, and you have to give the geoid model to which we have to convert the orthometric height. If you do not have a local geoid model, then we should go for global model like EGM08. By making use of that, our WGS84 coordinate of the control point has been converted to northeast and orthometric height. Now we should go to detailing part using the total station, and we should go for, I had shown you that for detailing work we can go either by radiation method or by intersection method. In the radiation method we will set up our instrument in one control point whose location already now available in the northeastern orthometric height. Then we should go to backside to some other control point whose location has also been established by using GPS and converted to NEH. So both of this NEH coordinate will be given, one as a station point, another is a backside point, and then we have to start the detailing that has been shown you in the field. So once the location of the different points has been collected, that will be stored in the total station memory as a digital data. Also I had discussed that if we cannot, sometimes we may not be able to set up our instrument, or it will be judicious as per the field to set up instrument at some other points other than the control points, but at least 2 control points should be visible and preferably 3, and I have shown you how to get the location of the instrument location from the control point location by method of resection. So once the instrument has been set up by method of resection, then the location of the instrument will be obtained from the location of the control points, and then we can do my method of radiation collection of different detailing data. So that has been shown you. Once the data has been collected, all this data will be available in digital form. Then all those data first has to be checked about the quality, as I told you, as per the specification, whether this data is meeting the specification or not. If it is fine, if it is not, then we have to go revisit to the field and take the data with better quality. Now once the data is available, digital data is available for mapping purpose, then those data will be imported to mapping software. And now mapping software, I had shown you that it can be independently planimetric mapping, independently contour mapping, then we can merge together to go for topographic mapping. In some other cases it may be your 3D topographic map. So whatever it is, most of the working steps are same. In fact, making the planimetric map, contouring map will be more detailed. So I had taken up that as a case study. And once the map has been prepared, then we should go for detailing of this map like cartographic elements. The most important things that has to be represented in the map is the scale and preferably graphical mode of scale and the north direction, the legend chart. These are the things which are very important and we have to note it down. So, this is what we have discussed in this course. Hope you have understood many of the points, and if you go through something more from these books, you will be able to have more understanding about the content of this course. Hope you enjoy this course and you have learned and you will be able to implement this in your future life. Thank you.